ਇਹ ਤੁਸੀਂ ਸਕਰੀਨ ਉੱਤੇ ਕੀ ਦੇਖ ਰਹੇ ਹੋ? ਹਾਂ, ਇਹ ਇੱਕ ਟਰਾਂਜ਼ਿਸਟਰ ਜਾਂ ਰੇਡੀਓ ਦਾ ਐਕਚੁਅਲ ਸਰਕਿਟ ਹੈ ਅਤੇ ਇਹ ਇਸ ਦੇ ਇੰਟਰਨਲ ਇਲੈਕਟ੍ਰੀਕਲ ਕੰਪੋਨੈਂਟਸ ਹਨ। ਇਹਨਾਂ ਵਿੱਚ ਕੀ ਤੁਸੀਂ ਇਹ ਛੋਟੇ-ਛੋਟੇ ਲੰਬੇ ਅਤੇ ਗੋਲਾਕਾਰ ਕੰਪੋਨੈਂਟਸ ਦੇਖ ਸਕਦੇ ਹੋ, ਜਿਨ੍ਹਾਂ ਉੱਤੇ ਕਲਰਡ ਰਿੰਗਸ ਬਣੇ ਹੋਏ ਹਨ? ਇਹ ਕੰਪੋਨੈਂਟਸ ਰੈਜ਼ਿਸਟੈਂਸਸ ਹਨ ਅਤੇ ਇਹਨਾਂ ਉੱਤੇ ਕਲਰਡ ਰਿੰਗਸ ਡਿਜ਼ਾਈਨਸ ਨਹੀਂ ਹਨ, ਬਲਕਿ ਇਹਨਾਂ ਦਾ ਇੱਕ ਖਾਸ ਸਾਇੰਟਿਫਿਕ ਮੀਨਿੰਗ ਹੈ। ਇਹ ਰਿੰਗਸ ਓਮਸ ਵਿੱਚ ਰੈਜ਼ਿਸਟੈਂਸਸ ਦੀਆਂ ਵੈਲਿਊਜ਼ ਇੰਡੀਕੇਟ ਕਰਦੇ ਹਨ। ਫਿਰ ਇਹ ਵੀ ਸੋਚੋ ਕਿ ਇੱਕ ਸਰਕਿਟ ਵਿੱਚ ਇੰਨੇ ਸਾਰੇ ਰੈਜ਼ਿਸਟਰਸ ਕਿਉਂ ਯੂਜ਼ ਹੋ ਰਹੇ ਹਨ। ਅੱਜ ਦੇ ਇਸ ਲੈਸਨ ਵਿੱਚ ਅਸੀਂ ਪੜ੍ਹਾਂਗੇ ਕਿ ਕਿਸੇ ਸਰਕਿਟ ਵਿੱਚ ਇੱਕ ਤੋਂ ਜ਼ਿਆਦਾ ਰੈਜ਼ਿਸਟਰਸ ਕਿਉਂ ਹੁੰਦੇ ਹਨ ਅਤੇ ਕਲਰਡ ਰਿੰਗਸ ਦਾ ਸਹੀ ਮੀਨਿੰਗ ਕੀ ਹੈ।
Dear students, you are all welcome to this class of resistances and combinations of resistances from the chapter Electric Current and Resistance. ਸ਼ੁਰੂ ਕਰਦੇ ਹਾਂ ਇਹ ਜਾਣਨ ਨਾਲ ਕਿ ਰੈਜ਼ਿਸਟਰਸ ਕਿਹੜੀ ਚੀਜ਼ ਦੇ ਬਣੇ ਹੁੰਦੇ ਹਨ। ਆਮ ਤੌਰ ਤੇ ਇਹ ਲੋੜੀਂਦੀ ਮਾਤਰਾ ਵਿੱਚ ਪਾਊਡਰਡ ਕਾਰਬਨ ਜਾਂ ਗ੍ਰੇਫਾਈਟ ਨਾਲ ਬਣਦੇ ਹਨ। ਬਾਰੀਕ ਪੀਸੀ ਹੋਈ ਕਾਰਬਨ ਡਸਟ ਜਾਂ ਗ੍ਰੇਫਾਈਟ ਨੂੰ ਇੱਕ ਨਾਨ ਕੰਡਕਟਿੰਗ ਸਿਰੈਮਿਕ ਪਾਊਡਰ ਨਾਲ ਬਾਈਂਡ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਕਾਰਬਨ ਅਤੇ ਸਿਰੈਮਿਕ ਦਾ ਰੇਸ਼ੀਓ ਮਿਕਸਚਰ ਦੀ ਓਵਰਆਲ ਰੈਜ਼ਿਸਟਿਵ ਵੈਲਿਊ ਡਿਟਰਮਿਨ ਕਰਦਾ ਹੈ। ਇਹ ਰੇਸ਼ੀਓ ਜਿੰਨਾ ਹਾਈ ਹੁੰਦਾ ਹੈ, ਰੈਜ਼ਿਸਟੈਂਸ ਉਨੀ ਹੀ ਲੋ ਹੁੰਦੀ ਹੈ। ਹੁਣ ਇਸ ਮਿਕਸਚਰ ਨੂੰ ਸਿਲੈਂਡਰੀਕਲ ਸ਼ੇਪ ਵਿੱਚ ਮੋਲਡ ਕਰਕੇ ਅਤੇ ਆਊਟਰ ਇਨਸੂਲੇਟਿੰਗ ਮਟੀਰੀਅਲ ਨਾਲ ਕੋਟ ਕਰਨ ਤੋਂ ਪਹਿਲਾਂ ਇਲੈਕਟ੍ਰੀਕਲ ਕਨੈਕਸ਼ਨ ਦੇਣ ਲਈ ਦੋਨੋਂ ਐਂਡਸ ਤੇ ਮੈਟਲ ਵਾਇਰਸ ਜਾਂ ਲੀਡਸ ਅਟੈਚ ਕੀਤੀਆਂ ਜਾਂਦੀਆਂ ਹਨ। ਲਾਸਟ ਵਿੱਚ ਇਸ ਉੱਤੇ ਕਲਰ ਕੋਡ ਮਾਰਕ ਹੁੰਦੇ ਹਨ।
The resistors are actually one of the most common parts of any of the circuits or devices. Depending on the specific requirement, the resistances of various values and accuracies are available in the market for all sorts of practical purposes. The value and their percentage accuracy are indicated on carbon resistors with the help of 4 colored rings printed on them. 3 of the colored rings are towards one end of the ring, and the 4th is near the other. Both the particular color and its placement on the ring have their own specific meaning. The detailed meaning of the color and positions of these colored rings is called the color code for a given carbon resistance. The understanding will be better with the help of this table. So, the black represents 0, brown represents 1, and red is for 2. Then orange is for 3, yellow for 4, and green for 5. The color blue shows 6. The color violet shows 7. Grey shows 8, and the white shows 9. Finally, there are gold or silver rings at the other end of a resistor. The gold or the silver rings represent the percentage accuracy or the tolerance limit of the resistor. Here the gold is for 5% tolerance and the silver stands for 10% tolerance. Also, if there is no ring in this place, the accuracy of no color is 20%.
ਮੈਂ ਤੁਹਾਨੂੰ ਇੱਕ ਤੋਂ ਬੜੇ ਹੀ ਇੰਟਰਸਟਿੰਗ ਸੈਂਟੈਂਸਸ ਦੱਸਦੀ ਹਾਂ ਜਿਨ੍ਹਾਂ ਦੀ ਮਦਦ ਨਾਲ ਕਲਰ ਕੋਡ ਆਸਾਨੀ ਨਾਲ ਯਾਦ ਰੱਖਿਆ ਜਾ ਸਕਦਾ ਹੈ। ਸੈਂਟੈਂਸਸ ਦੇ ਹਰ ਵਰਡ ਦਾ ਫਰਸਟ ਬੋਲਡ ਐਲਫਾਬੈਟ ਉਸੇ ਲੈਟਰ ਨਾਲ ਸ਼ੁਰੂ ਹੋਣ ਵਾਲੇ ਕਲਰ ਵੱਲ ਸੰਕੇਤ ਕਰਦਾ ਹੈ। ਬੀਬੀ ਰॉय, ਗ੍ਰੇਟ ਬ੍ਰਿਟਨ, had a very good wife wearing gold silver necklace. ਦੂਜਾ ਸੈਂਟੈਂਸ ਹੈ black brown rods of your gate became very good when given silver color. ਕਲਰ ਕੋਡ ਨੂੰ ਰੀਡ ਕਰਨ ਲਈ ਕੁਝ ਰੂਲਸ ਹਨ ਜਿਹੜੇ ਤੁਹਾਨੂੰ ਯਾਦ ਰੱਖਣੇ ਹੋਣਗੇ। Let me tell you the rules for reading the color code on a resistor first. Let us consider an example. Just look at this resistor.
The resistor should be held in such a manner that the gold or silver ring is always on the right side. The colors on strips are noted from left to right. Color of the first strip A from the end indicates the first significant figure of resistance in ohm. Color of the second strip B indicates the second significant figure of resistance in ohm. The color of the third strip indicates the decimal multiplier, that is, the number of zeros that will follow after the two significant figures. The color of fourth strip R indicates the tolerance limit of the resistance value or percentage accuracy of resistance. If fourth colored strip does not exist, then tolerance is to be taken as 20%. Can we read the value of this resistor according to the color code? The first ring from the left is orange. The second is also orange. The third one is red, and the fourth is golden. The first and the second ring indicate number 3 each. Thus, the first two digits read 33. The multiplier reads 2. So the number 33 is to be multiplied by 10 raised to the power 2. The final value of the resistor becomes 33 into 10 raised to the power 2 ohm, or 3.3 into 10 raised to the power 3 ohm, or 3.3 kilo ohm.
Tolerance of the given resistor is 5% as the last ring is golden in color.
Let us now read the value of one more resistor. The colors on it, as seen from left side, are red, violet, green, and then golden. The first red ring reads number 2. The second, violet, reads the number 7. Thus, the first two rings represent the first two digits as 27. The color in place of the multiplier or the power of 10 is green, which means 5, or 10 raised to the power 5. Thus, the value of the resistor becomes 27 into 10 raised to the power 5 ohms, or in standard notation 2.7 into 10 raised to the power 6 ohm. Again, the ring giving the value of tolerance of the resistor is golden. Thus, the tolerance for this case also is 5%. आज ਅਸੀਂ resistors ਦੀ ਗੱਲ ਕਰ ਰਹੇ ਹਾਂ ਜਿਹੜੇ ਹੁਣ ਤੱਕ ਬਣੇ ਹਰ ਸੰਭਵ ਇਲੈਕਟ੍ਰੀਕਲ ਔਰ ਇਲੈਕਟ੍ਰੋਨਿਕ ਡਿਵਾਈਸਸ ਦੇ ਬੇਹੱਦ ਜ਼ਰੂਰੀ ਹਿੱਸੇ ਹਨ। ਅਸੀਂ ਇਹਨਾਂ ਡਿਵਾਈਸਸ ਤੋਂ ਜਿੱਦਾਂ ਦੀ ਪਰਫੈਕਟ ਪਰਫਾਰਮੈਂਸ ਦੀ ਆਸ ਰੱਖਦੇ ਹਾਂ, ਉਸ ਲਈ ਇਹਨਾਂ ਦੇ ਕੰਪੋਨੈਂਟਸ ਦੀਆਂ ਸਪੈਸੀਫਿਕੇਸ਼ਨਸ ਵੀ ਹਾਈ ਪ੍ਰੈਸੀਜਨ ਨਾਲ ਕੈਲਕੂਲੇਟ ਕੀਤੀਆਂ ਜਾਣੀਆਂ ਚਾਹੀਦੀਆਂ ਹਨ। Obtaining the desired values of the specifications of electrical components is practically a very difficult task. Truly speaking, the ideal situations exist in the books only. The resistors in the market have certain fixed values only. The resistors are also available in multiples and sub-multiples of these 17 different numbers and their multiples. That is 10, 12, 15, 18, 20, 22, 27, 30, 33, 39, 47, 51, 56, 68, 75, 82 and 91. So, you can have resistances of values 0.1 ohms, 0.12 ohms, 0.15 ohms, 0.18 ohms, etc. or 1.0 ohms, 1.2 ohms, 1.8 ohms, 2.0 ohms and so on, or in multiples 10 ohms, 12 ohms, 15 ohms, 18 ohms, 20 ohms, 22 ohms or like that up to 91 ohms. The multiples of the order of kilo ohms or mega ohms are also available in the same order. So, if you need a resistance of 1.6 ohms or say 70 kilo ohm for a particular circuit, then how and from where to get that? Well, thankfully, the resistances have a wonderful ability of getting added in two different ways when connected in two specific ways in a given circuit. Actually, two or more resistances connected in a circuit to give a different result in whatever manner is called a combination of resistances. Also, without keeping you in suspense, let me tell you that the resistances can be connected in series with each other or in parallel to each other. The actual effect of the resistances in a combination circuit is called the net resistance or effective resistance or the resultant resistance or even the equivalent resistance. Come, let me first show you the two types of combinations of resistances before I highlight their special features. This diagram shows a circuit diagram containing three resistances respectively connected in series with each other and also with a source of current. In this kind of a connection, the resistances are connected in such a way that the current through each of the components is the same and the voltage across the components is the sum of the voltages across all the components. Components connected in series are connected along a single path. So, the same current flows through all of the components. Now, look at this diagram also. This is a circuit diagram showing three resistances connected in parallel with each other and also with a source of current. In this kind of a connection, voltage across each of the components is the same and the total current is the sum of the currents through all the components. Let us now get to understand them one by one in detail. So, we begin with the series combination of resistances. Resistors are said to be connected in series if the same current is flowing through each resistor when some potential difference is applied across the combination. If the three resistances R1, R2 and R3 are connected as shown in this diagram, they are said to be connected in series. Let V be the potential difference applied across A and B using the battery. In series combination, the same current, say I, will be passing through each resistance. Let V1, V2 and V3 be the potential difference across R1, R2 and R3 respectively. According to Ohm's law, V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. Here V is equal to V1 plus V2 plus V3, which becomes equal to IR1 plus IR2 plus IR3 or I into R1 plus R2 plus R3. Let this be equation 1. If Rs be the equivalent resistance of the given series combination of resistances as shown in this diagram, then the potential difference across A and B is given by V equal to IRs. This is equation 2. From equations 1 and 2, we can write IRs equal to I into R1 plus R2 plus R3. This directly implies Rs equal to R1 plus R2 plus R3. Thus, the equivalent resistance of a number of resistors connected in series is equal to the algebraic sum of individual resistances. It shows that the value of equivalent resistance of series combination of resistors is always greater than the resistance of individual resistors. Therefore, the resistors are to be connected in series if the effective resistance in the circuit is desired to be increased. In a series resistance circuit, there are 5 main points to be noted. First, the current is same in every resistor. Secondly, the current in the circuit is independent of the relative positions of the various resistors in the series. Thirdly, the voltage across any resistor is directly proportional to the resistance of that resistor. Fourthly, the total resistance in the circuit is equal to the sum of the individual resistances, including the internal resistance of a cell, if any. And finally, the total resistance in the series circuit is more than the greatest one in the circuit. ਚਲੋ ਹੁਣ ਇਸੇ ਤਰ੍ਹਾਂ ਰੈਜ਼ਿਸਟੈਂਸਸ ਦੇ ਪੈਰਲਲ ਕੰਬੀਨੇਸ਼ਨ ਨੂੰ ਵੀ ਐਨਾਲਾਈਜ਼ ਕਰਦੇ ਹਾਂ ਤਾਂ ਕਿ ਇਸ ਨੂੰ ਵੀ ਪੂਰੀ ਤਰ੍ਹਾਂ ਸਮਝਿਆ ਜਾ ਸਕੇ। ਸੋ ਨਾਓ we talk of resistances in parallel. As I told you, a number of resistors are said to be connected in parallel if potential difference across each of them is the same and is equal to the applied potential difference. If 3 resistances R1, R2 and R3 are connected as shown in this diagram, they are said to be connected in parallel. Let V be the potential difference applied across A and B with the help of a cell or a battery. Let I be the main current in the circuit from battery and I1, I2 and I3 be the currents through the resistances R1, R2 and R3 respectively. Then I is equal to I1 plus I2 plus I3. We will call this relation as equation 1. Here, potential difference across each resistor is V. Therefore, using Ohm's law, we write V is equal to I1 R1, which is equal to I2 R2 and also to I3 R3. Or I1 is equal to V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. Putting these values of I1, I2 and I3 in equation 1, we get I equal to V by R1 plus V by R2 plus V by R3. Let this be equation 2. Thus, if Rp be the equivalent resistance of the given parallel combination of resistances, then according to Ohm's law, V is equal to I into Rp or I is equal to V by Rp. Let us write this relation as equation 3. Now, from equations 2 and 3, we write V by Rp is equal to V by R1 plus V by R2 plus V by R3, or 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Thus, the reciprocal of equivalent resistances of number of resistors connected in parallel is equal to the sum of the reciprocals of the individual resistances. It shows that the value of equivalent resistance of parallel combination of resistors is always less than the resistance of each of individual resistors. Therefore, the resistors are to be connected in parallel if the effective resistance in the circuit is to be decreased. For a parallel resistance circuit, there are 5 main aspects to be emphasized upon. First, the potential difference across each resistor is the same and is equal to the applied potential difference. Second, the current through each resistor is inversely proportional to the resistance of that resistor. Third, the total current through the parallel combination is the sum of the individual currents through the various resistors. Fourth, the reciprocal of the total resistance of the parallel combination is equal to the sum of the reciprocals of the individual resistances. And finally, the total resistance in parallel combination is less than the least resistance used in the circuit. Overall, we may conclude that when resistances are connected in series, the current through each resistance is the same. When the resistances are in parallel, the potential difference across each resistance is the same and not the current. Also, remember that we have made calculations for series and parallel combinations of 3 resistances each, but the formula can be generalized for any number of resistances, which may be more than one. Students, ਹੁਣ ਅਸੀਂ ਰੈਜ਼ਿਸਟੈਂਸਸ ਦੇ ਸੀਰੀਜ਼ ਐਂਡ ਪੈਰਲਲ ਕੰਬੀਨੇਸ਼ਨਸ ਦੇ ਮੈਥਮੈਟੀਕਲ ਐਕਸਪ੍ਰੈਸ਼ਨਸ ਤੇ ਬੇਸਡ ਕੁਝ ਨਿਊਮੈਰੀਕਲ ਕੁਐਸਚਨਸ ਆਸਾਨੀ ਨਾਲ ਸੋਲਵ ਕਰ ਸਕਦੇ ਹਾਂ. So, let us try our hand on these problems one by one. Look at this simple one first, where the resistances are connected in mixed combination of series and parallel connections. Look at this diagram before listening to the question. Calculate the effective resistance of the circuit and the amount of current flowing through it. For the solution, if you look at the diagram carefully, the resistances R1 and R2 are in parallel combination with each other. Let us name this combination as A. Similarly, the resistances R3 and R4 are in parallel combination with each other. Let us name this combination as B. The combinations A and B are in series with each other. Thus, all that we have to do in order to solve this question is to first find the resistances of A and B individually and then add them up to give the effective resistance of the circuit. We can then calculate the current through the circuit using the Ohm's law. So, here we go for the solution. R1 is equal to 100 ohms, R2 is equal to 250 ohms, R3 is equal to 350 ohms, R4 is equal to 200 ohms and V is equal to 24 volts. Using the formula for effective resistance of a parallel combination for group A resistances, 1 by Ra is equal to 1 by R1 plus 1 by R2. And substituting the values of R1 and R2 in this equation, we get 1 by Ra equal to 1 by 100 plus 1 by 250. This gives us 1 by Ra as equal to 5 plus 2 upon 500, or Ra is equal to 500 by 7 or 71.428 ohms. And now to calculate Rb, we use the same formula, that is 1 by Rb equal to 1 by R3 plus 1 by R4. Substituting the values of R3 and R4 in this equation, we have 1 by Rb equal to 1 by 350 plus 1 by 200. This gives us 1 by Rb equal to 4 plus 7 upon 1400, or Rb is equal to 1400 by 11 or 127.272 ohms. And now the total effective resistance Re is equal to Ra plus Rb, or equal to 71.428 plus 127.272, which is equal to 198.7 ohm. Using Ohm's law, that is I is equal to V by R, and putting the values of V and R in it, we get I equal to 24 by 198.7 or equal to 0.1207 amperes. Here is another problem. Find the current drawn from a cell of EMF 1 volt and internal resistance 2 by 3 ohm connected to the network shown in the diagram. I is the current drawn by the network from the cell. The solution goes like this. According to the question, EMF of the cell is equal to 1 volt and internal resistance of the cell represented by small r is equal to 2 by 3 ohm. The network shown here can be simplified and redrawn like this. Each of the sub-networks 1 and 2 is a parallel combination of two resistances of 1 ohm each. Further, the two sub-networks 1 and 2 are in series with each other. If R dash is the effective resistance of the sub-networks 1 and 2, then R dash is equal to 1 into 1 upon 1 plus 1 plus 1 into 1 upon 1 plus 1, or equal to half plus half, that is 1 ohm. The same network is now also equivalent to the arrangement as shown in this diagram. If R be the equivalent resistance of the network ABCD, then 1 upon R is equal to 1 upon 1 plus 1 upon 1 plus 1 upon 1, which is equivalent to 3 upon 1. Now, if 1 by R is equal to 3 upon 1, then R is clearly equal to 1 by 3 ohm. Therefore, the current in the circuit I is equal to E upon R plus internal resistance small r equal to 1 upon 1 by 3 plus 2 by 3, which simply comes out to be equal to 1 ampere. And now get ready to answer some of my questions. My first question is, what should be the color code marking on a resistor to represent a resistance of 62 ohm? The color code starting from left should be blue, red and then black, where Blue represents the first significant figure, that is 6. Red represents the second significant figure, that is 2. And black is the number of zeros, which is 0 here. Another question is, in which kind of connection the potential difference across each resistance of the combination remains the same? The answer is, the potential difference across each resistance remains the same when the resistances are in parallel connection. ਇਸ ਤੋਂ ਪਹਿਲਾਂ ਕਿ ਮੈਂ ਅੱਜ ਤੁਹਾਡੇ ਕੋਲੋਂ ਇਜਾਜ਼ਤ ਲਵਾਂ, ਪਾਠ ਧਿਆਨ ਨਾਲ ਸੁਣਨ ਲਈ ਮੈਂ ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਧੰਨਵਾਦ ਕਰਨਾ ਚਾਹਾਂਗੀ। ਆਸ ਹੈ ਕਿ ਤੁਸੀਂ ਕਲਾਸ ਦਾ ਭਰਪੂਰ ਫਾਇਦਾ ਲਿਆ ਹੋਵੇਗਾ ਅਤੇ ਇਸ ਵਿੱਚ ਦੱਸੀਆਂ ਗਈਆਂ ਗੱਲਾਂ ਦਾ ਪੂਰਾ ਲਾਭ ਉਠਾਓਗੇ। ਥੈਂਕ ਯੂ ਐਂਡ ਗੁੱਡ ਬਾਏ until the next class.